Okay, so today we are talking about gradient. So when we refer to the gradient of a line, this is a measure of its slope. So when we're talking about slope, we are talking about how steep a line is. It's calculated by considering how far the line has risen or fallen between 2 points within a given distance, so within a given horizontal distance. So we call the horizontal distance our run and our vertical distance the rise. So there's a few different formulas. The most common formula is just rise over run. Our second formula here, the m equals y2 minus y1 over x2 minus x2. This is how we'd find the gradient if we had 2 points. So we'd have our 2 points of x1, y1, x2, y2. And we just substitute those values into our formula and it gives us the gradient. The other way we can think of it is our gradient is our change in our y divided by the change in our x. Now we always work from left to right, so we're always considering that our run is positive because we're going positively in the positive direction along the x-axis. And our y value, if we're going up, we're going to have a positive. If we're going down, we're going to have a negative. So we have 4 different types of gradients. We can have a positive, negative, zero, or undefined. Some examples of positive gradients include these lines here. So we can see that all of these arrows, they start at the left-hand side and they move upwards as you go across the x-axis. Over here we have the negative gradients. And we can say as we move across from left to right for these ones, they're going downwards. For a zero gradient, so the first one we have our positive gradients. So this is what we were looking at in this section where we were looking at our positive gradients. Our second one we were looking at our negative gradients. And now we're going to look at a zero gradient. So a zero gradient is just a horizontal line. So you're not moving up or down, you're not going anywhere really, you're just going from left to right. So it's a zero gradient. An undefined gradient is a gradient that is a vertical line. So it's not going left or right at all, it's just going up. So if we think about our positive gradients, these are where our m is going to be a positive number. A negative is when m is going to equal a minus number. A zero gradient, our m is going to equal 0, and our undefined m equals, it's undefined, that's what undefined means, because if we were to put them into our formula, so rise over run, for this one here we'd have a rise of 0, a run of, could be anything, let's say 3, a rise of 0, run of 3, that's just going to give you 0. Over here, we could have a rise of 3, but our run is 0. You cannot divide by a 0 number. This does not exist. The gradient of a line can be found using the formula of rise over run, or our difference of 2 coordinate pairs. Finding the gradient, so first we need to identify 2 points on the slope. If we start with the point furthest to the left, calculate the run, so how far across that goes to our next point. And then we need to determine if we need to move up or down to get to the next point. If we're moving up, we have a positive. If we're moving down, we have a negative. And then you calculate the number of units that you've risen up or down, and then you write the gradient as rise over run. So in our first question here, question A, I'm going to pick the point here and the point here. They're nice and easy points. They're crossing one of our axes. So our first one, so our m is going to equal, we've gone across 1, so our run is going to be 1, and we've gone up 1, 2, 3, so our rise is going to be 3. So our gradient is going to be 3. In B, I'm going to pick the point here and the point here, only because those 2 points cross the axes at whole numbers, so it's nice and easy to use. So our m equals, I'm going to do my run first. So 1, 2, 3, 4, 5, 6. So I've gone across 6, and now I'm going down. So this is going to be a negative number, 1, 2, 3. We can simplify that to -1/2. So that's the gradient in B. For C, I've been given 2 points. Our first point over here is -4, 3, and one over here is 3, 5. Now you can choose to do either of the formulas. You can do rise over run, or you can do the difference. So if we do rise over run, we're going to have M equals, we've gone across 1, 2, 3, 4, 5, 6, 7. So we've gone across 7, and then we're going up. So we're going to be positive. We've gone up 2. All right, now if we were using the formula, we need to look at our 2 points. So first point, so if I say that this is my first coordinate, this one is my second coordinate, then we would have, for our rise, we would have 5 minus 3 divided by 3 minus 4. That's going to equal 2 over, a minus and a minus makes a positive, so 2 over 7. So we're going to get the same answer either way. It's a positive gradient, so we've got a positive number, which is all good. For this one here, if we do rise over run, M equals, so we've gone across 1, so our run is 1, and then we've gone down. So we know this is going to be a negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The better way of doing it though, so our gradient is going to be -10. If we look at the difference in our points, so our first coordinate up here is going across to -3 and up to 5, and our point down here is going across -2 and down to -5. So if I say this is point 1, this is point 2, doesn't matter which order you do them in, you'll get the right answer either way. So my y value, so -5 minus 5 divided by -2 minus -3. So that's going to give us a -10 on the top. This -3 here will give us a +1 at the bottom, which gives us our -10. Okay, our next one here, we have a horizontal line. So we automatically know that M is going to equal 0. If we did want to put it into our formula, we will have M equals our y value, which is 5 minus 5 divided by 3 minus 3. So we get 0 over 6, which again will just give us 0. For F, we've been given our coordinates, so it's going to be much easier to use our formula. So I'm going to say this is 1, this is 2. So my y value and my x values, so 5 minus 3. That's going to give us a 2 and a 2. So our gradient in this case is just going to be